So you have a full sheet of paper and then a half sheet of paper. Okay? The half sheet of paper we want to fold in half again. And just either tear it or cut it so that you have two pieces like this. Okay? The full sheet of paper we want to fold in half. And then we want to fold this out here. And then I want to fold this here. So if you look at it straight on, it looks like an M. Or, to avoid confusion, a W. Okay? So make a Y out of it. And on the Y, on this together section, we want to try to figure out where halfway is and cut up to the fold. I'm not cutting past the fold, I'm cutting up to the fold. And on the bottom half, I'm going to do the same thing, cut that in half. And on the top half, I'm going to do the same thing and cut that in half. I'm going to take my fourth piece of the paper, I'm going to weave these through. Like that. And then I want to weave this one through the opposite way. So that we have this foldable. Okay? Now, I'm going to use this one for the video just because it shows up better on the whiteboard screen than it does on the video. I know the video, the pink and green one showed it fine, but this one will be better for the projecting in class. Okay? Ready? So, at this point, it doesn't matter what side you're on. Like, it doesn't matter at all. So don't freak out about that. Okay? I have mine on this side. You can have yours however you want. But don't do it this way. Okay? Okay. Here we go. In this first top section right here, I'm going to write y equals negative f of x. And on this side, I'm going to write y equals f of negative x. You can't see it. Hold on. There. Yeah, it's ornery sometimes. Thank you for letting me know, though. Now, as we go through this foldable that we're making today, we are going to be talking about words like inside and outside of the function. We're going to be talking about horizontal and vertical. We're going to be talking about stretch and compression. We're going to be talking about shifts, all sorts of stuff like that. Okay? So, looking at these two functions right here, compare the two functions. Where is the negative sign of this function compared to the negative side of this function? Where is this one? Outside, right? If it's outside, that's going to cause a vertical change. Okay? Outside the function causes a vertical change. So, any ideas what happens when it's inside? Horizontal change. Now a negative sign causes a very specific type of change. Yes, it's vertical, yes, it's horizontal, but the type of change it causes is a reflection. Now it can't just be a reflection, because then why do we even have two different functions then, right? It needs to be something more specific than that. Well, think about it. If I have a function that's right here, and it makes a vertical change, what is it reflecting across? If it's going from here to here, what is it reflecting across? X-axis, right? So this is a reflection over the x-axis. Well, This one you know is causing a reflection, and you know it's a horizontal change, so it's going from here to here. What kind of change is that reflecting across? The y-axis. Good. Now in the bottom section of each one of these, we're going to draw some graphs. I'm going to zoom way in so that they're much easier to see. Okay? Maybe not that far in. Okay. So I need to be able to draw 2 graphs in each section. So I'm going to draw out the coordinate plane so that I make sure to have enough room to begin with. And then we'll talk about specifically what are we graphing. Okay? So in this first one, y equals 2 to the x power. I know you all remember exactly what we did on Thursday and Friday of last week with the parent functions, right? So you all already automatically remember what this looks like. You know that the variable's in the exponent, so this is exponential. And you know this number is greater than 1, so you know that this is exponential growth, right? What happens if I take this function and reflect it over the x-axis? So first of all, it starts there and goes down. Is that decay? Decay starts here and goes down this way. It's not decay, it's just a reflection of growth. Does that make sense? It's kind of weird. I don't care. You're fine. Okay? So for this other one, let's use y equals the square root of x. And y equals the square root of negative x. So if you'll remember, y equals the square root of x looks something like that. If I take this and reflect it across the y-axis, what's it going to look like? Like that, right? Any questions so far? Good? What's wrong? Yeah, for sure. This is what the parent function looks like. I know it's a reflection over the y-axis, so I took it here and reflected it across the y-axis. So instead of going up and to the right, it's going to go up and to the left. That makes sense? Okay. So now I'm going to zoom out a little bit so you can see the whole thing again. Yes, ma'am. That's just what it is. Yeah. I'm going to zoom out a little bit so you can see the whole thing. Okay? Because eventually this section right over here is going to be our cover. So this is, yeah, I turned it over. Here's the side we were just on, and then I flipped it over. Okay? This section right here is going to eventually be our cover, so let's put a title on our cover. What should we call this? Transformations. I know mine's crooked, but if I write it straight, it goes off the end of the page. Yes, that whole thing is the front cover. This whole section right here. Okay? Well, if this is the front cover, what do you think this side is going to be? So the back side, the back cover. So what should we have on the back cover? Yeah, please don't write my name. Please write your name. Okay? Yeah. Yeah. I mean, you can if you want, but I'd rather you have your name there. Okay? Now I'm going to zoom in so we can get back to the middle section and see it a little bit easier. You okay with that? Okay. So top section, y equals a times f of x. And other one, y equals f of bx. Y equals a times f of x, and then y equals f of bx. So we have 2 new things here. What are they? An a and a b. Where is the a compared to the function, and where is the b compared to the function? So the A is outside and the B is inside, right? So if the A is outside, what kind of change does that cause? Yeah, vertical change. Now, I saw something cool just then. I saw somebody go like this and flip it over to what we just saw. Because you knew we had talked about outside and we knew that said vertical, so you're looking back at what you know. That's awesome. Okay? Now, we're not going to write change this time because this has a very specific type of change. Okay? It's a multiplier, and multipliers cause a stretch or a compression, depending on the value of A. Well, if A is greater than 1, logically, what do you think that will cause? Will it be bigger or smaller? A stretch, right? And if it's between 0 and 1, what do you think that's going to cause? Compression. Good job guessing it, seeing as how it was the only answer left. Look at B. You said B was inside? Yeah? What kind of change is that going to cause? Horizontal. But because it's a multiplier, what kind of change is it going to cause? A horizontal what? Stretch or compression. Okay? Now, the weird thing about stuff inside the function is that it's like wonky of what you think it should be. I don't want to say opposite. I don't want to say backwards, because opposite implies a negative sign, right? Doesn't really do that. It's just weird of what you think it should be. Because if the multiplier is inside, like this B value, if B is greater than 1, what do you think it should be? A stretch, right? What is it actually? A compression. And if it's between 0 and 1, what do you think it should be? A compression, but what is it actually? Yep. Guess what we're drawing in the last sections? Yep. For this first one, let's use y equals x to the third. So let's use y equals 4 x to the third for that one. I'll zoom in so you can see these better. The graphs are kind of hard to see. Whoa. For this one, let's use y equals the cube root of x. And for this one, let's use y equals the cube root of 4x. Now I know you remember what cube root looks like, so I'll just draw it for you. Ish, right? We're just freehanding it, so we're not trying to get exactly perfect here. Guys, if this is a 4x, it's a number that's outside, that's multiplying, so that's going to cause a vertical stretch. Well, if it's causing a vertical stretch, I'm taking the original parent function and I'm stretching it this way. Does that make sense? So what's actually going to happen to the function is it's going to go like this. Does that make sense? If I pull this and stretch it like a balloon, does it make sense that we get closer to the y-axis? Okay. Now, somebody earlier said, but it looks like you just took it from the sides and mashed it in. Well, that's true, isn't it? Without these equations here, you can't tell me if this is a vertical stretch or a horizontal compression. You can't. The equations is what tells you which one it is. Okay? So you remember that this one looks like this. The cube root of x. So this is a multiplier on the inside. It's a 4, which is greater than 1, so it is a horizontal compression, which means I do take the sides and mash them in, which would squash that way down like that. Does that make sense? Okay. Now, for those of you that don't know the secret about this, you're about to find out the secret. Because I still have some more notes that I have to take. But I don't have any more room, do I? Or do you? So, not the side we put the labels on for front and the back. Go to the other side, fold it in, and open it up. What? Are you calling me a witch again? I think it's pretty neat myself. If you don't think it's cool, I don't care, because I do. Okay? Got it? So we have 2 more columns to make notes for. Okay? 2 more columns. I need to get a white piece of paper behind here so it doesn't freak out. Okay. So here we have y equals f of x plus k. And here we have y equals f of x minus h. So what's the difference here than the example we just did? These values are being added or subtracted, right? They're not being multiplied. What we just did was multiplied, which causes a vertical stretch or compression. Or horizontal stretch or compression, right? When it's being added or subtracted, first of all, is this k inside or outside? Outside, so it's going to cause a vertical change. Specifically, because it's being added or subtracted, how do you think it's going to change? Vertical, it's going to go either up or down. That's exactly right. Okay? So we call that a shift. Now, I need you to stop what you're doing, and I need you to look up at the board. Because I need to tell you something that's very, very important, and it will be important for the entire school year, and it's important enough that I'm making you put everything down and look up at the board. Got it? Everyone's looking at the board, right? This F is so important because if you forget it, it's a whole nother word. Please don't forget this F when we're talking about vertical changes. It's super important. I don't want it to show up on anybody's test. Not that that's ever happened before. For the record, the person that did it, I knew it was an accident because when I showed her, she went straight beet red and was worried that I was about to write her up. She wrote curse words on my test. But all I could do was just giggle because she wrote that on my test. You know what I'm saying? Where is this H? Inside. If it's inside, it causes a... It is a horizontal shift. Once again, what are you remembering? Your F. Because this gives me a very strange mental picture. I don't know how you do that. I'm just saying. So if K is positive versus K is negative. If K is positive, which way do you think it shifts? Well, we're going vertically, so up, right? And if K is negative, which way do you think it shifts? Down. Because that's logical, right? What happens here, though? If it's x minus h versus if it's x plus h, which way do you think we're going to go if it's x minus h? I think I should go left because it's minus, but I go to the right. Remember, it's wonky of what we think, right? So x plus h, which direction should I go? Now, this one Some of the other ones aren't as obvious. This one's super obvious. Why? Can I show you real quick? Look up at the original equation real fast. X minus h. Guys, the minus is part of the equation. So if it says x minus 2, what's the actual value of h? Just 2, which is why we go to the right. Does that make sense? If it says x plus 3, what's the actual value of h? Negative 3, because it says x plus 3, right? Which is why we go right down here to the left, because the actual value of h is negative 3. But to be fair, most people remember it's wonky of what we think, and if it's inside, we say x minus h, which means I have to go to the right. You okay with that? But that's really the mathematical reason. Like, I want you to know the mathematical reason. That's the mathematical reason. Okay? All right, let's draw our graphs. What's up? This one? Is that better? Okay, no. No, you're fine. It's a good question. I just forgot to put it. What shape does absolute value make? Oh yeah, a V. Yeah. So where is this moving? It's outside, so it's going to move up 2. This is a parabola, so it's more like a U. Where is it moving? It says x minus 1, so right 1. Any questions?